Hi, so here we are. We're on worksheet Q of the Are You Ready for Calculus? And this is some right angle trig. So you should know all of your right angle trigonometry, sine, cosine, tangent, cosecant, secant, cotangent in order to do this. I'm going to do some of this and you're going to finish the rest. Here we go. I love these problems. It should say let P be a point on the terminal side of theta. That's an angle. We're going to find all 6 trig functions of theta. Oh, I have a surprise for you. Answers need not be rationalized. Calculus, you don't have to rationalize the denominator. Surprise, that's my gift to you. Okay, ready? Here we go. Plot that point P, but just tell me what quadrant this is in. What quadrant would that be in? Hold on, X is positive and Y is positive, so you're going to go out 15 and up 8. Do you like how I went out 15 and up 8? Okay. Do you see that? Make a right triangle. And there's your theta. I didn't draw my axes. Great. Okay, label the sides that were given to you. So you were given an x value of 15 and a y value of 8. So you go to the right 15 and up 8. Now we need the hypotenuse. So what are you going to use to find that hypotenuse? Pythag, 15 squared plus 8 squared equals c squared. All right, so we went ahead and found the hypotenuse. Had a little brain thing there. Okay, now that you have all 3 sides of the right triangle, read the instructions. We're going to find all 6 trig functions. So make sure you write sine of theta. So sine is equal to opposite over hypotenuse. And this should be review. So if you're going, how is she doing this? Where is this coming from? You need to go check your trig notes from the school year. Or look up right triangle trig. Tangent is equal to opposite over hypotenuse, so 8 over 17. Okay, then we have the reciprocal identities. Reciprocal means you flip. So cosecant is the reciprocal of sine, so the reciprocal here would be 17 over 8. Secant is the reciprocal of cosine. Did I make a mistake? I told you I was going to zone. Oh, look, I just stop. Hold on. Oh, I'm wasting time on the video. Sorry. All right. Tangent is 8 over 15. My apologies. Secant. Did I get that right? Oh, silly. Yes, I had it right. Okay, cotangent. Sometimes I have trouble focusing. Everyone okay? Do we agree? So we're going to do the same thing here and here. I bet the numbers will be uglier than here. So have fun with that. We're going to go on. Now this says if tangent, so they gave us tangent, is in quadrant 3. So draw quadrant 3 only. See how I have 1, 2, 3? Draw an angle. And we're going to make our right triangle. It's called a reference triangle, like that. We're in quadrant 3. Now if they gave us tangent is 12 over 5, then that means we know 2 of the sides. You agree that's a 12? Yeah? Okay. So tangent's equal to opposite over adjacent. So opposite theta is going to be 12, and adjacent to theta is 5, like that. Now if they're in quadrant 3, what are these, positive or negative? I know they both look positive right now, but really we went to the left 5 and down 12, excuse me. So they're both negative. But when you divide them to get tangent, that's why they become positive. A negative divided by negative is positive. Okay, can we find the third side? Who has it memorized? If you have 5 and 12, anyone know what the hypotenuse is? It's going to be 13. So that's a good one to memorize. 5, 12, 13, and the 3, 4, 5. Those are the 2 I have memorized. I think there's one of 24 and 25, but I forget. Okay, now do we have to find all 6 or just what? Just sine and cosine, so that's nice. So the sine of theta will be the opposite over the hypotenuse. And the cosine of theta is the adjacent over the hypotenuse. Good? Okay, we're going to do pretty much all of 5 and 6 together, and you can go back and finish those ones that we skipped. So when we're talking about trig on the unit circle, here we have positive, positive in quadrant 1. So let's make a little chart, Q1. Here the x is negative, but the y is positive in quadrant 2. Quadrant 3, they're both negative, right? And quadrant 4, we have positive, negative. Okay, what else we have to know is what are the trig functions on the unit circle. So what is sine equal to on the unit circle? Every y value, and then the cosine is equal to the x value. Okay? So find the quadrants where the following is true. This says sine is greater than 0. So we're trying to figure out where y is greater than 0 because sine is y. So what two quadrants are all the y values positive? So that would be quadrant 1 and quadrant 2. And we also want the cosine to be negative. So the cosine are the x values, and the x values are negative in quadrants 2 and 3. So what we need to figure out, where is sine positive and cosine is negative? So which one of these overlaps? Quadrant 2. So only in quadrant 2, and if you look right here, do you agree, our little chart, that the sine value is positive and that the cosine value is negative? And that only happens in quadrant 2. So that's the answer here, quadrant 2. The quadrants are normally, not normally, they are Roman numerals, okay? All right, now let's look at cosecant. Cosecant is the reciprocal of which function? Sine. So the way I remember is that C goes with S and S goes with C. So cosecant is 1 over sine. And what is sine equal to on the unit circle? Sine is equal to y. Just because we do the reciprocal doesn't mean it changes the positive or negative, okay? So if we want y to be negative, well, 1 over y will be negative. So y negative, 1 over y is negative, same thing. So where are the y values less than 0? So here in what quadrants? So 3 and 4, because we want y to be negative, which is below the x-axis. So we're here in quadrants 3 and 4. Okay, cotangent. We haven't talked about this. So what's tangent equal to with x's and y's? So y over x, or sine over cosine, which is y over x. So cotangent is going to be the reciprocal of that, x over y. So we want x over y to be greater than 0. So we want x divided by y to be positive. Now when you divide two numbers, how do they come out positive? Yeah, if they're the same or if they're different. Sorry, if they're the same or the same, right? If they're different signs, they would come out, they would divide to be negative, but if they're the same signs, they divide to be positive. So what quadrants have the same signs? 1 and 3. So let's answer the question. Where is the cosecant negative and the cotangent positive? Which one was repeated twice? Quadrant 3. C says, where are all functions negative? Where do you see two negatives here? Yeah, but what about the tangent here? The tangent would be positive, right? So is there a quadrant where all functions are negative? No, there's not. I'm assuming when it says all functions that we're talking about all 6 trig functions. So, okay. I'm gonna explain these to you as we go. You ready? First thing we should do is you tell me what sometimes like when you don't know what to do, you have to just say, what can I do? So look at this, 5a. What can you do? Sorry, 6. You can divide by 5. So let's do that. Let's divide by 5. Okay. So this kind of has to do with range and our graph. Do you have this sine graph memorized in your head? Like, do you know what it looks like and what it bounces between? So what this is saying is, which of the following is possible? Can sine equal -2/5? Think about this. Here's what you should know about the graph of sine. You should know it starts where? Where does it starts at 0, and where does it go to? 1. And then it goes to 0, and then it goes to -1. And it kind of looks like that. Oops. Yep. Can sine equal -2/5? Hold on. It went up to 1, down to 0, down to -1. Did it pass through -2/5 here? Yeah, it did. Yeah? It's all about well, what is the fraction for what's the decimal for 2/5? Do you guys know? And it's negative. So that's like, right, oops, a little less than 1/2, yeah? So is this possible? Yes. What if I said sine of x equals +6? Is that possible? Does it go up to 6? No, it bounces between -1 and 1. So if you're always wondering what the heck is range for, like this is an example of where we're using range, yeah? Can sine equal 6? No, not possible. Because sine lives between -1 and 1. It bounces between -1 and 1. Okay? Okay. This is a fun one. I had to look this one up. I'm going to be honest. Ready? Tell me, I just told you. You tell me, what is the largest value sine can equal? The largest value is 1. So let's pretend that this is the largest value of 1. And what's the largest value that cosine can be? The biggest value. Also 1, right? So if we use the maximums 1 and 1, what's 3 plus, then we have 3 plus 4, which is 7. Can 7 ever reach 8? No. Well, what if we use the negative numbers? Well, we could use 0. That wouldn't equal 8. -1 wouldn't equal 8. So do you see that? Isn't that an interesting question? I had to look it up, I'll be honest. Okay, real quick. What should we do here with this tangent? Yeah, let's isolate it. So let's get it by itself. If you didn't use the word isolate, that's okay. You will when you're a math teacher. Okay. So let's subtract 22 and we get, what is that? 63? Everyone okay with that? I'm not okay with that because I would rather it be divisible by 8, but that's okay. Can the tangent equal 63/8? So this is almost like saying, what's the range of tangent? We haven't graphed that in a long time. I guess here's a question for everyone. Do you know when tangent is undefined? It's not at 0, it's at, tangent is undefined at pi/2 and 3 pi/2. And if you look at a unit circle, that would remind you. Other than that, tangent can equal anything. So everyone, this is yes, possible. If I know how to spell possible, 2 S's.